So in this class, let us going to discuss something about the characteristics of a potable water and how the water is purified for domestic water supply and what are the requirements for a water to be used for industrial purpose. Let us see one by one. So a list of characteristics parameters to be possessed by potable water, that is water supplied for domestic purpose, should possess, which are prescribed by WHO and ICMR. So the water should be clear, optically clear. It should be colorless, odorless, cool, pleasant to taste. So the temperature is very important for water. Free from bacteria and suspended impurities, which are very important for a good potable water. And it should be free from the dissolved gases like carbon dioxide, which will make the water acidic, and hydrogen sulfide will give bad smell, and ammonia also, and some poisonous materials like lead, arsenic, manganese, and so on. And when we are coming to that physicochemical parameters, hardness of water should be less than 150 ppm, and chloride concentration, chloride not Cl2, chloride concentration should be less than 250 ppm, and total dissolved solids should be less than 500 ppm, and pH, it should be in the neutral pH. It should lie in the range between 6.5 to 8. Then only the water can be used without any problem for household purposes. And the water which we are getting by various sources are not having all these characteristic properties, so it has to be purified through various stages to get pure water for domestic water supply. So these are the various stages we have for the supply, for the water to be supplied for domestic purpose. Screening, it is very, very simple thing. Screening, aeration, sedimentation, coagulation, filtration, and the important process, the last step is sterilization, nothing but disinfection, removing the bacteria and other things. So what do you mean by screening? It is very simple. The name itself indicating the meaning of screening is just to screen something. So when you are taking water, it may contain some solid impurities floating in it. So anything which is suspended can be removed by filtration, that is called screening. So water, let me say water is collected from river sources or from well. It may contain some materials, inert materials, sometimes leaves, plant leaves, and some wooden particles. So that has to be screened before it is taken for the next process, that is called screening. By removal of suspended impurities like leaves, wood, and other inert material can be called as screening. So water which is holding these impurities are passed through a screen. That means like a filter, when we pass it, so the screening, so we have another one, filtration. There is a wide difference between these two. The first one is just to remove the floating objects. So some floating thing alone can be removed here. We are not removing all the fine particles. That is not done here, because we are having so many other processes there that can be removed. Here the floating objects alone screen by passing the water through a filter or through a screen. It is called screening. It is differing from our filtration. Filtration will remove still smaller and smaller particles. And next one is aeration. It is very simple. The name itself explaining the meaning. Aeration is nothing but just by mixing the water with air, that's all. So air is bubbled through it, or water is allowed to fall from some height. So water is mixed with air. When water is mixed with air, what will happen? Some dissolved gases like CO2 and other poisonous gases may be swept out. It will come out. Especially hydrogen sulfide and carbon dioxide, ammonia, or any other dissolved gases that will be removed. That is one thing. So nothing but mixing with excess of air, it removes dissolved gases like ammonia, carbon dioxide, hydrogen sulfide, and other odor giving compounds. Gases are removed. So besides the removal of gases, one more important thing is also happening. Certain metals, certain metal ions, which are converted into insoluble precipitates. The best example we can take here are Fe3 plus and Mn2 plus. So these are in soluble form in absence of excess of air, whereas when we are passing air, this Fe3 plus and manganese salts are converted into the respective precipitates, so they can settle down. As the hydroxides, these hydroxides are insoluble, so you can. So screening just to remove the floating objects, and aeration, it is to remove mainly the gases like ammonia, carbon dioxide, hydrogen sulfide, and to convert soluble metal ions into insoluble metal hydroxides. So the next one is sedimentation. So sedimentation, see that meaning, if we are allowing the water to settle down in a tank, when it is allowed to settle down, the particle settles down on its gravity. So here we are not going for any mechanical means, or we are not adding any chemical in sedimentation. We are just allowing the water to remain in the tank. So the third step in the treatment of water for domestic supply is sedimentation. Sedimentation is nothing but removal of suspended impurities by allowing the water to stand on a tank, very big tank, undisturbed for 2 to 6 hours. Due to the force of gravity, the particles settle down. That's all. So no mechanical means, no chemicals are added here. So the removal of suspended impurities by allowing the water to stand in a big tank undisturbed, that is more important, for 2 to 6 hours, the particles settles down due to the force of gravity, is called sedimentation. But by this sedimentation technique, only 75% of the suspended impurities alone can be removed. So why the 25% is not removed? So reason is very obvious. So the 25% of the particles are having still smaller in size, so they do not settle down. That is, they are finely divided, then the particles settle down here, and thereby they are not getting settled down. So such finely divided suspended particles can be removed by the next technique, coagulation, by adding some chemicals. So the sedimentation is carried out without adding any chemicals, whereas this coagulation is to remove finely divided clay, silica, which do not settle down during sedimentation, are made to settle down by adding some coagulating agents like alum or aluminum sulfate So these chemicals are making the clay and silica to settle down as a precipitate. So how this settlement takes place? How the particles are made to settle down? So this aluminum sulfate or alum. Alum is a double salt. It is also having aluminum sulfate, potassium sulfate, aluminum sulfate, 24H2. This is a formula. So this alum also contains aluminum sulfate. That aluminum sulfate undergo hydrolysis to form aluminum hydroxide. So this aluminum hydroxide precipitate, it is a gelatinous white precipitate. It is a gelatinous precipitate. So that means the precipitate is having the particle size close to colloid. It is not having that much big particle size like our conventional precipitate. So the gelatinous white precipitate entraps the finely divided colloidal particles or clay, silica to settle down with it. So the settlement is fastened by adding such coagulating agents, and this coagulation is mainly for the settling down the particles of clay, silica which do not settle down in the normal course in sedimentation. So the next step is filtration. So this filtration is always carried out with the help of some filter beds. We will see that later. So filtration is to remove bacteria, not all, only partially it can be removed, and color, that means color causing substances are filtered off, that's all. So color goes, and taste, that means the substances which are imparting some taste to water is removed, and similarly substances which are giving some odor, smell to the water also removed, and suspended impurities very well can be removed by passing the water through filter bed. So this filtration is done by passing the water through a filter bed. It is having various layers of sand, fine sand, we will see the diagram, coarse sand, like that one by one we are arranged in order. So in that, when you are allowing the water to pass down, bacteria, color, taste, odor and suspended particles are removed, that is by filtration. Let us see the diagram of that filtration. So here is the fifth step in the treatment of water for domestic supply, that is our filtration. See the term itself explaining the meaning of filtration. It is just to remove the suspended impurities, that's the meaning of filtration. But in this filtration, even the minute particles, bacteria can be removed. Bacteria, color causing substances, odor causing substances, and some of the toxic materials present in water are removed. So these bacteria, toxic substances and other impurities are filtered by passing the water through a filter bed as shown here in the diagram. So the first layer is made up of fine sand, coarse sand, followed by coarse sand, fine gravel, coarse gravel, like that they are arranged in this bed. On the top, when this impure water is allowed to pass through, the fine particles are retained by the fine sand itself, and that water which is filtered by the fine sand bed going through the next one, coarse, final gravel, coarse, and finally in the bottom we are getting the pure water. So this how far, how long, for how many days or for how many hours or how much water can be purified by this bed depends on the impurities present in water, and how often depends only on impurities present in water, and most of the impurities are retained by the fine sand bed itself we have to renew this often to get the process effective one. So that's all about filtration. So the sixth step in the treatment of water for domestic water supply is sterilization, disinfection, or is called as. It's very simple process of removing harmful bacteria. So here why I am specifying the term harmful, the chemical, is there any way to separate whether the bacteria is harmful or not? It's not like that. Just you are specifying it is harmful bacteria for clarity, that's all. So process of removing harmful bacteria by some chemicals is called sterilization, and the chemicals used for this purpose are called disinfectants. So without adding chemicals, even we have some methods for sterilization, that is boiling. It can be used mainly for household purpose. It cannot be used for large scale. Just by boiling water, not heating the water, boiling the water for 10 to 15 minutes, the bacteria is killed, and followed by filtration, that water can be used. But there is a disadvantage in this process. Normally when you are boiling water for 10 to 15 minutes, the boiled water may not have the taste of the unboiled water. So taste goes. And second thing is, this cannot be used for large scale. For municipal water supply, this cannot be used. So this is only for our household purpose. And of course, we have to sacrifice the taste to certain extent by the first method. So the second method is ozonation. It is carried out by passing ozone. So ozone, by using some ozone generator, ozone is prepared, which is passed through water. That is passed through water. Since ozone is highly unstable, it decomposes to give oxygen, O2. This has no any use here. Only this nascent oxygen, newly born oxygen, it is having better oxidizing property than even atomic oxygen, and it kills the bacteria in effective manner. But when you are comparing the advantage of this method with others, effect wise it is good, no doubt, but it is costlier when compared with other techniques. So this cannot be used for municipal water supply. So now we are moving to the third one, that is chlorination. Chlorination is carried out by passing chlorine, elemental chlorine gas, or by adding chloramine. Again it is involving chlorine. Chlorine and ammonia are taken the ratio 2:1, and that mixture is passed through water. And the third one is bleaching powder. Just we are adding bleaching powder into water. Let us see one by one. First one is chlorination. It is done by passing chlorine. Chlorine reacts with water, forming HOCl plus HCl. This HOCl is nothing but hypochlorous acid. So this hypochlorous acid is responsible for killing the bacteria. And when this hypochlorous acid decomposes to give HCl plus nascent oxygen, again the role of chlorine is to produce nascent oxygen, as we got nascent oxygen in the case of ozone. So the nascent oxygen only kills the bacteria. But we have a problem with this chlorine handling. Since it is a gas, passing chlorine is not that much better technique. And another one, if the water is having some hydrocarbons, then this chlorine will combine with such hydrocarbons, forming the compounds like chloroform, which is not good for health. And third one is under chlorination. The second technique is by adding chloramine. Chloramine is not obtained directly. It is obtained by mixing ammonia and chlorine in the ratio 2:1. It is bubbled through water. These two are reacting to give chloramine ClNH2 plus HCl. Here, which is the reagent responsible for killing the bacteria? Obviously, this chloramine. This chloramine decomposes to give chlorine. Decomposes to give chlorine. Here, this chlorine is trapped by ammonia in the form of chloramine, and this chloramine decomposes at a slower phase when compared with a slower phase giving chlorine in slow manner. That means it is not released at once. Once all the chlorine is released at once, it may escape. It may not be used by water for sterilization. So this chloramine decomposes slowly, giving chlorine gas, which again reacts with the water in the same way to give nascent oxygen, which is killing the bacteria. And the last one is bleaching powder. So bleaching powder is a solid, so we can add easily. There won't be any handling problem as we faced with the chlorine gas. We, according to the requirement or pollution load of water, we can add some quantity of bleaching powder into water. Normally, water will contain bacteria, organic impurities, Fe2 plus H2S, ammonia. Everything is removed besides our bacteria, which we specified earlier. So how this bleaching powder is responsible for sterilization? So the next method is by adding bleaching powder. Bleaching powder formula: CaOCl2, calcium oxy calcium hypochlorite. So bleaching powder reacts with water, giving calcium hydroxide plus chlorine, and this chlorine gas, as we specified in the previous method, combines with water, giving HCl plus HCl, and this hypochlorous acid is responsible for the sterilizing property. Not only for sterilizing property, it can oxidize the reducing substances like Fe2 plus hydrogen sulfide, and it can remove ammonia. So all are done by this hypochlorous acid. Now, how much chlorine we have to add? Either it is in the form of bleaching powder or chloramine or by passing any of the gases. How much chlorine we have to add, or how long we have to pass? Because chlorine, excess chlorine, unused chlorine should not remain in water. You might have smelled the chlorine in Sirwani water or any water. Any municipal supplied water will carry some chlorine smell. So the chlorine should not be excess. So the chlorine present in water after passing chlorine for disinfection is called residual chlorine. That's a Cl2. Residual means the elemental chlorine Cl2, not chloride, Cl2. So how much chlorine we have to pass? Of course, that is decided by the pollution load. By analyzing various physico-chemical parameters, we will be deciding how much chlorine we have to pass. So here there is a graph. So here is a plot showing the relationship between the amount of chlorine passed, that may be chlorine gas or bleaching powder or any other form, plotted with residual chlorine, that is amount of free chlorine present in water. So initially when you are passing chlorine, there is no residual chlorine appears. That means the chlorine which we passed is completely utilized for killing the bacteria and for the oxidation of reducing agents like Fe2 plus hydrogen sulfide. So it is used completely for that purpose, so no chlorine left over, residual chlorine is 0 in this label 1. When we pass chlorine further, the residual, that is amount of chlorine, residual chlorine increases due to the formation of chloramine, and after that there is a drop because the chlorine which we are passing is used for the destruction of chloramine and other chloro compounds formed. So the chlorine content, residual chlorine content decreases and we are reaching a minimum point. After that there is nothing to remove, reducible substances and bacteria, organic impurities, odor causing substances, color causing substances, toxic elements if any, all are oxidized by chlorine completely. So the chlorine which we are passing has no role, it appears as free residual chlorine. So the point at which free residual chlorine appears is called as breakpoint chlorination. So at this breakpoint chlorination, here all the impurities are removed, sterilization is 100%, so we are getting reasonably pure water for domestic water supply. These are the various methods of sterilization of water. So we have seen so many methods of purification for domestic water supply, and one more technique we have, that is using UV radiation. Since UV radiations are having very high energy, it can be used for sterilizing the water, and UV light we can get from mercury vapor. Mercury vapor lamp will give UV radiations. So water can be sterilized using this UV radiation. Since it is involving electricity, because to get mercury vapor lamp to glow we need electric energy, so it is costly and thereby it is not used for domestic water supply. That is, for municipal water supply this cannot be used. And in case if water is turbid, it cannot be used because turbid water leads to, with UV radiations, it undergo various undesirable changes, so we cannot use it. And in day-to-day practice, these UV radiations are used mainly for swimming pools. So in the two, not in ordinary swimming pools, the swimming pools which we have in hotels, so they are using UV radiations to sterilize the water. So it is costly, so we cannot afford it.